The first three steps of the functional development process are to clearly define the problem, create a test matrix, and to outline the solution or make an algorithm for that function. In this case, we defined our function we wanted it to calculate the time of death. It would use these inputs, and it would output time of death or an error message if these validation rules were not met. Here we basically expounded upon what type of inputs we could use for body temperature, room temperature, and time found, and what kind of outputs we could expect from each of these various inputs. We use this to test valid inputs, invalid inputs, and boundaries, or like the highs and the lows, so that we knew the extent of our function and how high we can go. Then we moved on to creating the algorithm, which we basically set up a simple function that used these variables: body temperature, room temperature, and time found. Here we put the validation rules, or if statements, to return an error if the validation rules were not met. And then this part is where we do the actual calculations. We take the variables given to us by the user and we put them in this little function to output the time of death. And then we would return the time of death up to the function.
The next step of the functional development process is to test the algorithm we created. How we test it? We just fill the test matrix and verify that the results we obtained are the ones we expect. For example, let's run through this one. Let's start with a value test. If body temperature is 32, room temperature is 20, and the time found is 9 o'clock. Let's see. First of all, is the body temperature numeric? Yes, it is. Is the room temperature numeric? Yes, it is too. Is time found a valid time? Yes, it is a valid time. Is body temperature higher than 42? No. Is it lower than the room temperature? No. So, let's assign these values to these two constants here, and let's calculate the time of death. So, time found minus 36.5 minus body temperature 32 divided by 1.5. Great. 6 o'clock is the time of death. Now let's go through some invalid tests. Let's suppose body temperature is invalid. What's going to happen? Well, to be caught here, body temperature is not numeric, so the function will return an error. For the next one, body temperature is numeric, but room temperature is not numeric, so it will return another error message. Last, body temperature is numeric 32, room temperature is numeric 20, but time found is not a valid time, so another error message. Let's go to some boundary tests. Body temperature 50, room temperature 20, and time found 11 o'clock. So, body temperature, room temperature, and time found are valid values. However, body temperature is higher than 42. It's 50, so the function will return an error message. Now, for this next test, every value is valid and body temperature is not higher than 42. However, it's lower than room temperature. It's 15, and room temperature is 20. So, another error message. Last, let's use some valid values again. Body temperature is numeric, Room temperature is numeric. Time found is also a valid time. Body temperature is not higher than 42, and body temperature is not lower than the room temperature, so the validation tests are okay. Now for our last calculation, well, since it's 5 in the afternoon, instead of using number 5, I use 17, just to use the 24 hours format for now. So 17 minus 36.5 minus, yeah, 17, divided by 1.5 for in the morning, so that's time of death. So after we walk through our algorithm and see that it's working as expected, just like we did here, we are ready to translate this algorithm into actual code. All we need to do is to translate each statement into Java statements. Well, in this particular case, the call time of that function already requires that the 3 parameters are of some specific types. If the user tries to input some valid values here, the function won't even run because some error will occur. So we are not going to translate these 3 statements. However, about the rest, we are going to do this. If body temperature higher than 42, return an error message. Otherwise, if body temperature is lower than room temperature, return error message. Well, I had to write this extra statement here in order to work with date and time. And then let's keep going. This statement here is here. And this calculation here and this return message are also here. After we translate the algorithm into actual code, we are ready now to test our code to see if when we run this code, we are going to receive the same results we had when we run the test matrix. Well, I created here a unit test for us to test this call time of that function. However, I won't explain it in more details now. I'll do it later by walking step by step. However, if I execute this test here, it shows every test worked fine. So we indeed receive the same results here as we received in the test matrix. And now the last step, if everything is working fine just like it is, we're ready to deploy the changes to the remote repository. We do this by first committing the changes. We just need to right-click our project, go to Git, commit, and of course, write some comment here to explain what you did. And also, it's a good practice to write the date and time you are doing this. Then you just click the commit button. However, I won't click anything now because I'm not really changing anything. And after doing this, you just send the changes to the repository by clicking Git, remote, and push. Okay, I know my computer is in another language, but yeah, it's written push, just believe me. Well, and these are the 7 steps. Clearly define the problem, create a test matrix, create the algorithm, test the algorithm through filling the test matrix, translate the algorithm to code, run test case, and deploy the change to the remote repository. Now we are going to explain about selection statements. There are 2 types of selection statements, if and switch. I'll talk about if now. It's pretty simple. The computer will evaluate if the condition inside the parentheses is true, and if it is, it executes the following block of code. In this case, if the body temperature variable is higher than 42, the computer will print body temperature too high and will assign the value false to the variable valid. But sometimes you may want the computer to do something else if this condition is not met. In this case, you just need to use the else keyword. If you use else, it will execute this code block if this condition is not met. But there are times you want to be even more specific, so you can use else if. In this case, what the code would do: if body temperature is higher than 42, the computer will execute this code block. Otherwise, if body temperature is lower than room temperature, the computer will execute this block. You may nest as many else if as you want in order to meet what you want to do. And at last, if none of the previous conditions are met, the computer will execute what's written in the else block.
This is our switch selection statement. It starts in a do-while loop so that we get all these options at least once before continuing on in the program. What we start with is an input from the user. Then we convert that input into uppercase so that the user doesn't have to hold shift while they are pressing any keys on the keyboard. Then the switch statement takes the input and it compares it to each of these cases. If it matches one of the cases, it'll then run the corresponding function, which in this case would be calc time of death, which if we scroll down here, you can find that calc time of death is right here, which sets up a new instance. And it runs that class, corresponding class. If the input by the user is not one of the above cases, then it prints out this invalid selection, try again, which prompts the user to go back and choose a different case. Then, so while that's running, it's always testing to see if the input is invalid. And if it is invalid, the valid variable will be false. When the valid variable is true, then it continues on and it'll run one of these corresponding functions.
Okay, now we're going to perform some unit tests in order to verify that our function is working as we planned and as we specified in the test matrix. Well, we'll test now a function we named calc search radius. This function requires three parameters: speed of travel, period time, and time of death. Speed of travel should be higher than 0 and equal or lower than 200. So let's start with a value test. Speed of travel will be 60. Current time 11 o'clock, time of death 9 o'clock. Now I'm going to create a new instance of the class that contains the calc search radius function. And according to these parameters, we expect the result to be 120. So we're going to put this value in the expect result variable. Now we're going to run the function and its return value will be assigned to the result variable. At last, we'll just check if both values are the same. But we can see here in the bottom part that both already have the same value, so this test is okay. Now for the next one, let's use a value which is just too high, 300. Current time will be 6, time of death 5, and since there will be an error, the expected result is -1. After running the function, we can see here the return value is indeed -1, so this test is okay too. Next one, we are going to use a value which is just too low, 0. Expected result should be -1 too, and the actual result is -1. Let's test. Let's just use the highest possible value, which is 200. According to these parameters, the expected result should be 200. The actual result was indeed 200. So this concludes this test case, and according to what we can see here, every test was okay.
The lifespan of a variable depends upon where it is declared. So in this case, in the case of the variable menu, it is declared within this class and not inside any functions. And so this string variable called menu. Its lifespan happens to be anytime within this class. So since this class starts up here and ends all the way down here, the variable menu lasts throughout the entire process of this class being executed. It also spans across any instances that are created because of this class. On the other hand, the variable input we have right here, it's a string and it's declared inside this function. And so this variable is only used within this function, and once this function has completed, or once this function has run through all the way, then this variable input it no longer represents anything.
Now we are going to explain a little the difference about passing variables by value and by reference to other functions. Well, when you pass a variable by value, you are allowing the computer to use its value as you may want, but any change that you may do won't be reflected back at the original variable. For example, here I'm creating a new instance of the suspect class. I'm using this function to assign an interim variable as 10. And here I'll just retrieve its value and assign to the time to location variable, so its value will be 10. When the computer executes this line of code, it just prints 10. Now here I'm going to pass this variable by value to the pass by value function. This function will just change its value from 10 to 4 and print it. However, when I go back to the function I was executing before, the computer won't print 4, it will print 10 because this change wasn't reflected back. This is what happens when you pass by reference, actually, and changes will be reflected back to the original variable. Also, in Java, when you pass a primitive data type variable to a function, like a string or an integer number, it will be passed by value always. It will pass by reference only when you pass objects. For example, this instance class here.
This is an example of passing variables by reference. So in this case, we take the suspect object, which was declared up here, and we run it through this function, pass by reference, which is down here. This function, it goes to the suspect class and runs the function getTimeAtLocation for this object, which we declared up here. And then it goes back to the suspect.java, the suspect class, and it runs this function to setTimeAtLocation, and it sets the value to 12. Now, then that goes back up here to this function that we're currently running, and it prints out the objects, and it runs this function, getTimeAtLocation, which retrieves this value that we stored in the suspect class.